Hello and welcome to another gentle journey through the mathematical universe, where numbers dance with nature and patterns whisper secrets of cosmic harmony. I'm delighted you've joined me tonight, wherever you might be finding your moment of peace. Perhaps you're curled up in your favorite reading chair, watching the last traces of daylight fade through your window, or maybe you're nestled beneath soft blankets as the world outside settles into evening's embrace. Take a moment to notice the rhythm of your breathing, the gentle weight of relaxation settling over your shoulders, the way the shadows grow longer and softer as night approaches. Wherever you are in this vast interconnected world, I hope this exploration of one of mathematics' most beautiful and mysterious patterns will serve as a soothing companion as you prepare for sleep. In the quiet moments of contemplation, when we allow ourselves to really notice the mathematical harmony that pervades existence, we connect with something larger than ourselves, a cosmic order that has been unfolding for billions of years and will continue long after we're gone. The Fibonacci sequence and golden ratio remind us that we're not separate from this cosmic order, but are integral parts of it, expressions of the same mathematical principles that create beauty and function throughout the natural world. This recognition can be profoundly comforting and inspiring. In a world that sometimes seems chaotic and unpredictable, the discovery of underlying mathematical order provides a sense of stability and meaning. We're reminded that despite surface appearances of randomness and disorder, deep patterns of beauty and harmony are constantly operating to organize and sustain the complexity of existence. The mathematical beauty we've explored tonight offers a unique form of peace and wonder, a way of seeing the world that reveals the extraordinary within the ordinary and the eternal within the temporal. When we learn to see with mathematical eyes, every natural form becomes a revelation, every artistic creation becomes a participation in cosmic harmony, and every moment of appreciation becomes a connection to the deepest structures of reality. As you drift off to sleep tonight, perhaps you'll carry with you some sense of this mathematical wonder. In your dreams, you might find yourself spiraling along golden curves that connect the chambers of seashells to the arms of galaxies, dancing to rhythms that follow Fibonacci progressions, or simply floating in the peaceful awareness that you're part of a mathematically harmonious cosmos, where beauty and truth are intimately connected. The Fibonacci sequence will continue its eternal dance through tomorrow and all the days that follow, guiding the growth of plants as they reach toward the sun, organizing the spiral arms of distant galaxies as they wheel through space, and creating patterns of beauty and efficiency that connect every scale of existence in one vast, interconnected mathematical symphony. When you wake, these patterns will still be there, waiting patiently for your renewed appreciation and wonder. Sweet dreams, fellow travelers in the realm of mathematical beauty. May your sleep be filled with golden spirals and Fibonacci sequences, with the peaceful recognition that you're part of a universe organized according to principles of profound elegance and harmony. The mathematical truths we've explored tonight are eternal and unchanging, connecting us across time and space to the fundamental structures that make existence both beautiful and comprehensible. Rest well, knowing that the same mathematical principles that create the beauty of flower petals and seashells also organize the neural networks of your sleeping brain and guide the cosmic dance of planets and stars. In the morning, the Fibonacci patterns will still be spiraling through nature and consciousness, ready to inspire new moments of wonder and new discoveries about the mathematical harmony that underlies all of existence. Good night, and may the mathematical beauty we've shared together bring you deep peace as you drift into the restorative embrace of sleep, carried along by the eternal spiral dance of numbers and nature, mind and cosmos, beauty and truth unified in the golden harmony that connects all things throughout the infinite expanse of mathematical reality. In the field of music, the connection between Fibonacci numbers and aesthetic appeal has been explored by composers and music theorists for centuries. Some have found that musical compositions based on Fibonacci proportions seem more pleasing and memorable than those based on other mathematical relationships. The Hungarian composer Béla Bartók incorporated Fibonacci numbers into the structure of several of his compositions, using them to determine the lengths of sections and the timing of climactic moments. More recently, electronic musicians have used Fibonacci sequences to generate rhythms and melodies that seem to capture something essential about the mathematical nature of musical harmony. The study of Fibonacci patterns in nature has also revealed surprising connections to physics and chemistry. Crystallographers have discovered that certain types of crystals, called quasicrystals, exhibit five-fold symmetry patterns related to the golden ratio, These crystals, which were once thought to be impossible, demonstrate that matter can organize itself according to mathematical principles that go beyond the simple periodic patterns of ordinary crystals. The discovery of quasicrystals earned Dan Shechtman the Nobel Prize in Chemistry and opened up new areas of research into the mathematical principles governing material properties. The golden ratio and Fibonacci sequence also play important roles in chaos theory and the study of nonlinear dynamical systems. Researchers have found that systems that exhibit chaotic behavior often pass through stages where their behavior is governed by Fibonacci-related mathematical relationships. The transition from order to chaos and back to order seems to follow patterns that involve the golden ratio and related numbers. This discovery has profound implications for our understanding of complex systems ranging from weather patterns to population dynamics to the behavior of financial markets. As we continue our exploration of these mathematical patterns, we encounter their manifestation in human physiology and psychology. The structure of the human circulatory system, with its branching network of arteries, veins, and capillaries, follows patterns closely related to Fibonacci numbers. The same is true for the nervous system, where the branching patterns of neurons and the organization of brain networks show similar mathematical relationships. Some researchers have suggested that these patterns are not coincidental but represent optimal solutions to the problem of distributing resources efficiently throughout a complex system. The respiratory system provides another beautiful example of Fibonacci patterns in human biology. The branching structure of the lungs, from the trachea through the bronchi to the tiny alveoli where gas exchange occurs, follows a pattern that maximizes surface area while minimizing energy cost. This fractal-like structure, with its Fibonacci-related proportions, allows the lungs to pack an enormous amount of surface area into a relatively small space, making efficient breathing possible. Even our sensory systems exhibit Fibonacci-related patterns. The structure of the human ear, particularly the cochlea where sound waves are converted into electrical signals, follows a spiral pattern closely related to the golden spiral. This mathematical organization may help explain why certain musical intervals and rhythms seem naturally pleasing to human ears. The visual system shows similar mathematical relationships, with the proportions of the eye and the arrangement of photoreceptors in the retina following patterns related to the golden ratio. The psychological effects of Fibonacci patterns and golden ratio proportions extend beyond simple aesthetic preference to influence our perception and cognition in subtle but important ways. Studies have shown that people process information more efficiently when it's presented in formats that follow these mathematical principles. Web designers and graphic artists have found that layouts based on the golden ratio are not only more visually appealing but also easier to navigate and understand. Kepler was particularly fascinated by the appearance of the golden ratio in the geometry of the regular pentagon, noting that this five-sided figure seemed to embody the same mathematical harmony that he observed in planetary motion. His laws of planetary motion, which describe the elliptical orbits of planets around the Sun, involve mathematical relationships that, while not exactly Fibonacci numbers, show related patterns of harmonic proportion. The scientific revolution of the 16th and 17th centuries established mathematics as the fundamental language of natural science, but it also raised profound philosophical questions about why mathematical patterns should be so effective in describing physical reality. Galileo expressed this mystery in his famous observation that the book of nature is written in mathematical characters, while Newton's discovery that the same mathematical laws govern both terrestrial and celestial phenomena suggested an underlying mathematical unity to the physical world. The development of calculus by Newton and Leibniz provided powerful new tools for studying the mathematical patterns underlying natural phenomena. Calculus revealed that many of the curves and spirals found in nature, including the golden spiral generated by Fibonacci rectangles, could be described by elegant mathematical equations. This discovery suggested that the visual beauty of natural forms reflects underlying mathematical harmonies that can be expressed through precise mathematical formulas. The 18th century Enlightenment saw further development of mathematical approaches to understanding natural beauty and harmony. Mathematicians like Leonhard Euler made fundamental contributions to the theory of spirals and geometric patterns, while philosophers like Immanuel Kant argued that mathematical beauty reflects the deep structure of human cognition itself. According to Kant, our appreciation for mathematical harmony reveals something fundamental about how the mind organizes experience. The 19th century brought new mathematical tools for studying the complex patterns found in nature. The development of non-Euclidean geometry showed that mathematical space could have different structures than the familiar flat geometry of everyday experience, while the emergence of group theory provided new ways to analyze the symmetries and patterns found in crystals and other natural forms. These mathematical advances laid the foundation for 20th century discoveries about the fractal and chaotic patterns that govern many natural phenomena. The 20th century saw an explosion of discoveries about the mathematical patterns underlying natural complexity. The development of computer technology made it possible to explore mathematical patterns with unprecedented precision and detail, revealing the fractal structure of coastlines, clouds, and biological forms. Scientists discovered that systems as diverse as weather patterns, population dynamics, and neural networks all exhibit mathematical relationships related to the golden ratio and Fibonacci numbers. The field of biomathematics emerged as researchers began to apply sophisticated mathematical techniques to understanding biological phenomena. They discovered that the growth patterns of plants, the branching structures of blood vessels, and the organization of neural networks all follow mathematical rules that optimize efficiency and functionality. These discoveries suggested that evolution itself operates according to mathematical principles, selecting for organisms whose structures and behaviors follow optimal mathematical patterns. Modern chaos theory has revealed that even apparently random natural phenomena often follow underlying mathematical patterns related to the golden ratio and Fibonacci numbers. The transition from order to chaos in dynamical systems frequently involves mathematical relationships that echo the proportional harmonies found in classical mathematics and art. This discovery has profound implications for understanding everything from weather prediction to economic forecasting to the dynamics of ecological systems. The development of fractal geometry in the late 20th century provided a mathematical framework for understanding the self-similar patterns that appear throughout nature. Fractals generated by simple mathematical rules can reproduce the complex branching patterns of trees, the irregular coastlines of islands, and the intricate structure of clouds with remarkable accuracy. Many of these fractal patterns incorporate Fibonacci numbers and golden ratio proportions, suggesting deep connections between different areas of mathematics and natural science. Contemporary research in network theory has revealed that the Fibonacci sequence and golden ratio appear in the structure of complex networks ranging from the internet to social media to biological neural networks. These discoveries suggest that the mathematical principles underlying natural beauty and harmony also govern the organization of information and communication in complex systems. The efficiency and robustness of networks seem to be enhanced when their structure follows patterns related to these fundamental mathematical relationships. The architectural and urban planning applications of Fibonacci principles are creating built environments that feel more natural and comfortable for human habitation. Buildings designed according to golden ratio proportions seem to promote well-being and productivity in their occupants. Urban spaces organized according to these mathematical principles create communities that feel more harmonious and connected. As more of humanity lives in cities, the incorporation of natural mathematical patterns into urban design may become crucial for maintaining psychological and social health. The agricultural applications of understanding Fibonacci patterns are leading to more efficient and sustainable farming practices. Crops arranged according to these patterns often achieve higher yields with less water and fertilizer. Greenhouse designs based on golden ratio proportions create optimal growing conditions with minimal energy input. Understanding the mathematical principles underlying natural plant growth may help us develop agricultural systems that work with natural processes rather than against them. The medical applications of Fibonacci patterns extend from diagnostic imaging to surgical planning to pharmaceutical design. Medical imaging systems that incorporate these mathematical principles can detect subtle abnormalities that might be missed by conventional approaches. Surgical instruments and procedures designed according to golden ratio proportions often achieve better outcomes with less trauma to patients. Drug molecules structured according to these patterns may be more effective and have fewer side effects than conventional designs. The communication and media applications of Fibonacci patterns are transforming how information is presented and processed. Websites and user interfaces designed according to these mathematical principles are easier to navigate and more pleasant to use. Advertising and marketing materials that incorporate golden ratio proportions are more effective at capturing and holding attention. As we move toward increasingly digital forms of communication, the incorporation of natural mathematical patterns may become essential for creating media that works in harmony with human psychology. The personal development applications of understanding Fibonacci patterns offer new approaches to self-improvement and spiritual growth. Meditation practices based on these mathematical relationships can induce profound states of peace and insight. Physical exercises and movements based on spiral patterns can improve health and vitality. Goal setting and life planning approaches that incorporate these proportional relationships often lead to more satisfying and sustainable outcomes. As our exploration of Fibonacci patterns draws toward its close, we're left with a profound sense of wonder at the mathematical harmony that pervades existence. These simple numerical relationships discovered through the contemplation of rabbit populations have revealed themselves to be fundamental organizing principles that operate throughout the natural world and human experience. They connect the smallest details of plant growth to the largest structures in the cosmos, link ancient artistic traditions to cutting-edge scientific research, and bridge the gap between objective mathematical truth and subjective aesthetic experience. The Fibonacci sequence and golden ratio represent more than just mathematical curiosities. They're glimpses into the deep structural principles that govern the organization of matter, energy, information, and consciousness throughout the universe. Their appearance in contexts as diverse as DNA molecules and spiral galaxies suggests that we're witnessing the signature of fundamental laws that operate at every scale of existence. These patterns remind us that the universe is not random or chaotic, but is organized according to elegant mathematical principles that we're capable of discovering and appreciating. The universality of these patterns across cultures, species, and scales of existence suggests that mathematical beauty is not merely a human invention but a fundamental feature of reality itself. The fact that we find golden ratio proportions aesthetically pleasing, that plants grow according to Fibonacci arrangements, and that galaxies spiral according to these same mathematical relationships points to a deep harmony between mind and cosmos, between consciousness and the mathematical structure of reality. The integration of Fibonacci patterns into virtual and augmented reality systems may create digital environments that feel more natural and comfortable than current artificial spaces. Video games and simulations based on these mathematical principles might be more engaging and less fatiguing than those designed according to other criteria. As we spend increasing amounts of time in digital environments, the incorporation of natural mathematical patterns may become crucial for maintaining psychological and physiological well-being. The study of Fibonacci patterns may also contribute to our understanding of consciousness and the nature of subjective experience. If these mathematical relationships are indeed fundamental to the way neural networks process information, then understanding them better might help us solve the hard problem of consciousness, explaining how subjective experience arises from objective physical processes. The mathematical beauty we perceive in Fibonacci patterns might provide clues about the deep structure of consciousness itself. As we approach the conclusion of our exploration tonight, it's worth reflecting on the profound implications of what we've discovered together. The Fibonacci sequence, which began as a simple exercise in counting rabbits, has revealed itself to be one of the fundamental organizing principles of the natural world. From the smallest flowers to the largest galaxies, from the structure of DNA to the proportions of the human body, from the branching of neural networks to the spiraling of hurricanes, this mathematical pattern appears with such consistency that it seems to represent a basic law of nature. The golden ratio, emerging naturally from the Fibonacci sequence as its limiting ratio, appears to embody some fundamental principle of optimal proportion and harmonious growth. Its appearance in art, architecture, music, and human psychology suggests that mathematical beauty is not merely a human invention but a deep feature of reality that we're naturally attuned to recognize and appreciate. The fact that systems optimized for efficiency and functionality often spontaneously develop golden ratio proportions suggests that mathematical beauty and practical utility are intimately connected. The universality of these patterns across such diverse domains, from quantum mechanics to cosmology, from molecular biology to human psychology, from ancient art to modern technology, suggests that we're glimpsing something fundamental about the mathematical structure of reality itself. The Fibonacci sequence and golden ratio may be signatures of deeper mathematical principles that govern the organization of information, energy, and matter throughout the universe. Perhaps most remarkably, these patterns reveal the deep interconnectedness of all things. The same mathematical relationships that govern the growth of a fern frond also appear in the structure of galaxies, The proportions that make a human face beautiful are the same ones that optimize the arrangement of seeds in a sunflower head. The rhythms that make music pleasing to our ears follow the same mathematical principles that govern the branching of our circulatory system. This suggests that we're not separate from nature but are integral parts of a vast interconnected mathematical symphony. The contemplation of Fibonacci patterns and the golden ratio offers us a unique form of meditation, a way of connecting with the underlying mathematical harmony that pervades existence. When we observe these patterns in nature or art, we're not just seeing beautiful forms but are glimpsing the fundamental mathematical principles that organize reality itself. This recognition can be deeply calming and centering, reminding us of our place in the cosmic order and our connection to the mathematical harmony that surrounds us. As you prepare for sleep tonight, perhaps you'll carry with you some sense of this mathematical wonder. The next time you see a spiral shell on the beach, notice the arrangement of petals on a flower, or simply hold out your arm and observe the proportions of your own body. You might remember that you're looking at expressions of the same mathematical principles that organize galaxies and guide the formation of atoms. You're witnessing the universe's preferred ways of organizing matter and energy, growth and form, beauty and function. In the quiet moments before sleep, when the day's concerns fade into the background, there's something deeply peaceful about contemplating these eternal mathematical truths. The Fibonacci sequence has been unfolding in nature for billions of years, long before humans existed to notice its patterns. It will continue to guide the growth of plants, the formation of galaxies, and the structure of living beings long after our civilization has become part of history. There's a profound comfort in this mathematical permanence, in knowing that some truths transcend the temporary concerns of daily life and connect us to the deepest structures of reality. The influence of these mathematical patterns extends far beyond the arts into modern technology and design. Computer graphics artists use the golden ratio to create visually appealing layouts and compositions. Industrial designers incorporate Fibonacci spirals into products ranging from smartphones to furniture. Architects continue to use these proportions in contemporary buildings, finding that structures designed according to these principles feel more harmonious and pleasing than those that ignore them. In the field of biology, the study of Fibonacci patterns has led to important insights into the mechanisms of growth and development. Scientists have discovered that the genes controlling leaf arrangement and flower development are sensitive to mathematical relationships involving the golden ratio. They found that cellular automata, simple computer programs that simulate the behavior of many interacting cells, naturally generate Fibonacci patterns under certain conditions. These discoveries suggest that the mathematical beauty we observe in nature emerges from the fundamental processes of life itself. The connection between mathematics and biology runs even deeper when we consider the structure of DNA, the molecule that carries genetic information in all living things. The DNA double helix exhibits proportions related to the golden ratio, with the length of a complete turn being related to the width of the helix by this special proportion. Some researchers have suggested that this relationship is not coincidental but reflects deeper mathematical principles governing the organization of genetic information. As we delve deeper into the realm of Fibonacci patterns, we encounter phenomena that challenge our understanding of how complex order can emerge from simple rules. Fractal geometry, the mathematical study of self-similar patterns that repeat at different scales, has revealed that many natural Fibonacci patterns are actually fractals. The branching patterns of trees, for example, show the same mathematical structure at the level of major branches, smaller branches, and tiny twigs. This self-similarity across scales suggests that the same simple mathematical rules operate at every level of organization. The study of fractals has revolutionized our understanding of natural patterns and has led to practical applications in fields ranging from computer graphics to medical imaging. Scientists use fractal mathematics to model everything from the structure of clouds to the behavior of financial markets. Engineers use fractal patterns to design more efficient antennas and heat exchangers. Artists use fractal algorithms to create complex naturalistic images that would be impossible to draw by hand. The connection between Fibonacci numbers and fractals becomes especially apparent when we consider the famous Mandelbrot set, a fractal pattern that emerges from a simple mathematical equation. Within the intricate, infinitely detailed boundary of the Mandelbrot set, Fibonacci numbers appear with surprising frequency, governing the arrangement of bulbs and filaments in this mathematical landscape. This discovery suggests deep connections between different areas of mathematics that mathematicians are still working to understand fully. The universality of Fibonacci patterns has also led to their application in fields as diverse as economics and computer science. The Fibonacci sequence appears in financial markets, where analysts use Fibonacci ratios to predict support and resistance levels in stock prices. Computer scientists use Fibonacci numbers in algorithms for searching and sorting data, finding that these mathematical relationships often lead to optimal performance. The sequence even appears in the analysis of internet traffic and the structure of computer networks. The practical applications of understanding these patterns, from healthcare to architecture, from agriculture to artificial intelligence, demonstrate that mathematical beauty and functional efficiency are intimately connected. Systems optimized according to Fibonacci principles often turn out to be not only more beautiful, but also more effective, sustainable, and harmonious with natural processes. This suggests that the pursuit of mathematical beauty is not merely an aesthetic luxury, but a practical necessity for creating technologies and systems that work in harmony with the deeper structures of reality. The educational and therapeutic value of these patterns reminds us that mathematics is not just an abstract intellectual exercise, but a doorway to understanding and appreciating the beauty and harmony that surround us. When we learn to see Fibonacci patterns in nature and art, we're not just acquiring mathematical knowledge, but developing a deeper capacity for wonder and appreciation that can enrich every aspect of our lives. The spiritual dimensions of these patterns offer a unique form of contemplative practice, a way of connecting with the underlying mathematical harmony that pervades existence. When we meditate on the golden spiral or contemplate the Fibonacci sequence, we're engaging in a form of spiritual practice that connects us to the fundamental structures of reality. This practice can be deeply calming and centering, reminding us of our place in the cosmic order and our connection to the mathematical harmony that underlies all existence. The continuing discovery of new applications and deeper understanding of these patterns reminds us that we're still in the early stages of comprehending their full significance. Each new scientific discovery, artistic application, and technological innovation reveals new facets of these mathematical relationships and deeper connections to other areas of knowledge. The story of Fibonacci patterns is far from complete. It's an ongoing exploration that promises to yield new insights and applications for generations to come. The social and cultural implications of these patterns suggest new approaches to creating communities and institutions that work in harmony with natural principles. Organizations designed according to mathematical principles related to the golden ratio often exhibit greater efficiency, resilience, and harmony than those structured according to other criteria. As we face global challenges requiring unprecedented cooperation and coordination, the mathematical principles revealed by Fibonacci patterns may guide us toward forms of social organization that are both more effective and more humane. The environmental significance of these patterns provides hope for developing sustainable technologies and practices that work with natural processes rather than against them. Understanding how natural systems achieve efficiency and beauty through mathematical organization can guide us in creating human systems that contribute to rather than detract from the health and harmony of the planet. The same mathematical principles that create the beauty of natural forms may help us design technologies that enhance rather than degrade the natural world. The cosmic significance of these patterns connects us to the largest questions about the nature of existence itself. The appearance of Fibonacci relationships in phenomena ranging from quantum mechanics to galactic structure suggests that these mathematical principles may be fundamental features of reality at every scale. This discovery invites us to consider whether mathematics is something we invent or something we discover, and what it means that the universe seems to be organized according to principles that we find both beautiful and comprehensible. The consciousness implications of these patterns raise profound questions about the nature of mind and its relationship to mathematical reality. The fact that we're naturally attuned to recognize and appreciate these mathematical relationships suggests something deep about the structure of consciousness and its connection to the mathematical organization of the cosmos. The study of Fibonacci patterns may ultimately contribute to our understanding of consciousness itself and the mystery of how subjective experience arises from objective physical processes. As we reach the end of our mathematical journey together, we're left with a transformed perspective on the world around us. The Fibonacci sequence and golden ratio are no longer just abstract mathematical concepts, but living principles that we can observe and appreciate in countless aspects of our daily experience. From the spiral of our coffee cup steam to the proportions of our own bodies, from the arrangement of flowers in a garden to the structure of the galaxy we inhabit, These mathematical relationships surround us with their quiet beauty and elegant functionality. The next time you walk through a garden and notice the arrangement of petals on a flower, or hold a seashell and observe its spiral chambers, or simply look in the mirror and contemplate the mathematical proportions of your own reflection, you'll be witnessing the same fundamental principles that organize stars into galaxies and guide the formation of crystals deep within the Earth. You'll be seeing the universe's preferred mathematical language made visible in the forms and patterns that surround us every day. The quantum mechanical implications of Fibonacci patterns suggest that these mathematical relationships may be built into the fundamental structure of matter and energy. The organization of electron orbitals in atoms, the behavior of particles in certain quantum systems, and the structure of elementary particles all show mathematical relationships related to the golden ratio. These discoveries hint that the mathematical beauty we observe at the macroscopic level may reflect even deeper mathematical principles governing the behavior of matter and energy at the most fundamental scales. The cosmological significance of Fibonacci patterns extends our understanding from the terrestrial to the universal. The spiral structure of galaxies, the organization of galaxy clusters, and the distribution of matter throughout the universe all show mathematical relationships related to these fundamental patterns. Computer simulations of cosmic evolution generate structures that follow Fibonacci-related mathematical relationships, suggesting that these patterns may be inevitable consequences of the way gravity and other fundamental forces shape the large-scale structure of the cosmos. The philosophical implications of the universality of Fibonacci patterns touch on some of the deepest questions in human thought. Why should mathematical relationships discovered through the study of number sequences appear so consistently throughout the natural world? What does this tell us about the nature of mathematics, the structure of reality, and the relationship between mind and cosmos? These questions have engaged philosophers and scientists for centuries and continue to challenge our understanding of the fundamental nature of existence. The aesthetic implications of Fibonacci patterns provide insights into the nature of beauty itself. The fact that proportions based on the golden ratio consistently appear in artworks, architectural masterpieces, and natural forms considered beautiful suggests that mathematical harmony may be a fundamental component of aesthetic experience. This doesn't reduce beauty to mere mathematics, but rather suggests that mathematical relationships may be one of the languages through which beauty speaks to us across cultures and throughout history. The spiritual dimensions of Fibonacci patterns have been recognized by contemplative traditions throughout history. The spiral has long been used as a symbol of spiritual growth, representing the journey from the outer world of material concerns to the inner world of spiritual realization. The golden ratio has been called the divine proportion, suggesting its role as a bridge between the mathematical and the sacred. Many spiritual practices incorporate spiral movements, breathing patterns, and meditative visualizations based on these mathematical relationships. The cultural universality of appreciation for Fibonacci patterns suggests that mathematical beauty may be one of the few truly universal human experiences. Across different cultures, historical periods, and artistic traditions, we find consistent appreciation for proportions and patterns based on the golden ratio and Fibonacci relationships. This universality hints at something fundamental about human consciousness and our relationship to the mathematical structure of reality. The continuing research into Fibonacci patterns reveals new applications and deeper understanding on a regular basis. Scientists studying plant growth have discovered new mechanisms by which genetic information produces Fibonacci arrangements. Researchers investigating animal behavior have found that optimal foraging strategies often follow Fibonacci-related patterns. Mathematicians continue to discover new connections between the Fibonacci sequence and other areas of mathematics, revealing an ever-expanding web of mathematical relationships. The role of Fibonacci patterns in artificial intelligence and machine learning provides insights into the nature of intelligence itself. Neural networks trained to recognize patterns in visual data often develop internal structures that mirror the mathematical relationships found in natural vision systems. Artificial systems optimized for efficiency and accuracy spontaneously discover the same proportional relationships that appear in biological systems. This convergence suggests that intelligence, whether natural or artificial, may naturally tend toward mathematical forms related to the golden ratio and Fibonacci patterns. The Renaissance artists weren't content to simply observe these patterns. They actively incorporated them into their work. Painters used the golden ratio to determine the proportions of their canvases and the placement of key elements within their compositions. Sculptors used it to create figures that seemed naturally harmonious and pleasing. Architects designed buildings whose proportions followed these mathematical principles. creating structures that felt inherently balanced and beautiful. The result was an art and architecture that seemed to resonate with something deep in human psychology, speaking to our innate appreciation for mathematical harmony. As we explore the Fibonacci sequence and golden ratio more deeply, we begin to understand that they represent something more than just curious mathematical coincidences. They appear to be fundamental organizing principles that operate at every scale of existence, from the quantum level to the cosmic level. In recent years, scientists have discovered Fibonacci patterns in the arrangement of electrons in certain materials, in the structure of DNA molecules, in the formation of crystals, in the branching patterns of blood vessels and neural networks, and in countless other natural phenomena. This universality suggests that the Fibonacci sequence and golden ratio may be built into the very laws of physics that govern our universe. Some physicists have proposed that these patterns emerge naturally from the way energy and matter organize themselves under the influence of fundamental forces. Others suggest that they represent optimal solutions to information processing problems that appear at every level of natural organization. Whatever the ultimate explanation, it's clear that these mathematical patterns are not mere curiosities, but fundamental features of the reality we inhabit. The study of Fibonacci numbers and the golden ratio has also revealed deep connections to other areas of mathematics. The sequence appears in probability theory, where it helps describe random walks and branching processes. It emerges in number theory, where it's connected to properties of prime numbers and continued fractions. It appears in geometry, where it helps describe optimal packing problems and tiling patterns. And it plays important roles in chaos theory and dynamical systems, where it helps describe the transition from order to chaos and back again. One of the most fascinating aspects of the Fibonacci sequence is its relationship to continued fractions, a way of representing numbers as infinite expressions involving whole numbers. The golden ratio has the simplest possible continued fraction representation. 1. This infinite expression captures something essential about the golden ratio's nature. It's built up from the simplest possible components, the number 1, through the simplest possible operations, addition and division, yet it creates something transcendent and beautiful. This simplicity underlying complexity is a recurring theme in mathematics and nature. The Fibonacci sequence starts with the simplest possible rule: add the previous two numbers, yet it generates patterns of incredible richness and beauty. The golden spiral begins with simple geometric construction, rectangles and quarter circles, yet it describes the shapes of galaxies and seashells with remarkable accuracy. This suggests something profound about the nature of reality, that the most complex and beautiful phenomena often arise from the simplest underlying principles. The psychological appeal of Fibonacci patterns and the golden ratio has been the subject of extensive research. Studies have shown that people do indeed find golden ratio proportions more aesthetically pleasing than other proportions, though the effect is subtle and not universal. Some researchers have proposed that this preference is hardwired into our brains, perhaps as a result of evolution in an environment filled with natural patterns that follow these mathematical principles. Others suggest that our appreciation for these patterns is learned, acquired through exposure to art and architecture that incorporates these proportions. Whatever the mechanism, there's no denying the powerful aesthetic appeal of Fibonacci patterns and golden ratio proportions. They appear in classical music, where composers have used Fibonacci numbers to determine the lengths of musical phrases and the proportions of musical forms. They appear in poetry, where poets have used Fibonacci sequences to structure verses and stanzas. They appear in dance, where choreographers have used golden ratio proportions to create movements that feel naturally balanced and flowing. The study of meditation and altered states of consciousness has revealed that certain types of mental states seem to enhance our ability to perceive mathematical patterns and relationships. Practitioners of contemplative disciplines often report experiencing reality as more mathematical and harmonious during deep meditative states, as if the underlying mathematical structure of existence becomes more directly perceptible when ordinary conceptual thinking is quieted. Research in positive psychology has shown that exposure to natural and artistic patterns based on the golden ratio and Fibonacci numbers can have measurable effects on mood, stress levels, and overall psychological well-being. Hospital patients recover more quickly when exposed to natural environments or artworks that incorporate these mathematical principles, suggesting that mathematical harmony may have therapeutic effects on human physiology and psychology. The therapeutic applications of Fibonacci patterns and golden ratio proportions are being explored in fields ranging from architecture to music therapy to garden design. Healthcare facilities designed according to these mathematical principles seem to promote healing and reduce stress in both patients and staff. Music composed using Fibonacci proportions appears to have calming and focusing effects on listeners. Gardens and landscape designs that incorporate golden ratio proportions create environments that people find particularly restorative and peaceful. The educational implications of Fibonacci patterns are profound, suggesting new approaches to teaching mathematics and science that emphasize the beauty and relevance of mathematical thinking. Students who learn about mathematics through the lens of natural patterns and artistic applications often develop deeper appreciation for the subject and better retention of mathematical concepts. This approach to mathematics education emphasizes discovery and wonder rather than rote calculation, helping students see mathematics as a living, beautiful aspect of the world around them. Contemporary art and design continue to find new applications for Fibonacci patterns and golden ratio proportions. Digital artists use these mathematical relationships to create computer-generated images and animations that seem naturally harmonious and appealing. Fashion designers incorporate these proportions into clothing and accessories that seem to enhance the natural beauty of the human form. Product designers use these mathematical principles to create tools and devices that feel comfortable and intuitive to use. The study of environmental design has revealed that spaces organized according to Fibonacci principles tend to be more psychologically comfortable and functionally efficient than those designed according to other mathematical relationships. Urban planners are beginning to incorporate these insights into the design of cities and neighborhoods, creating built environments that work in harmony with human psychological and physiological needs. As we consider the future implications of our growing understanding of Fibonacci patterns and their role in natural and human systems, we can anticipate exciting developments in fields ranging from biotechnology to space exploration. Scientists are already using insights from natural Fibonacci patterns to design more efficient solar cells, wind turbines, and other energy systems. The same mathematical principles that govern the arrangement of leaves on plants may help us design more efficient ways to capture and distribute energy. The exploration of other planets and solar systems may reveal whether Fibonacci patterns are universal features of all life-bearing worlds or unique to Earth's particular evolutionary history. The search for extraterrestrial intelligence includes looking for mathematical patterns in signals from space, and the discovery of Fibonacci-related patterns in alien communications would provide strong evidence for the fundamental nature of these mathematical relationships. The development of artificial life and artificial intelligence systems based on Fibonacci principles may lead to new technologies that are more efficient, robust, and aesthetically pleasing than current designs. Computer systems that process information according to golden ratio principles might be more compatible with human cognition and more intuitive to interact with. Robotic systems designed according to natural mathematical patterns might move more gracefully and efficiently than current mechanical designs. As biotechnology advances, we may develop the ability to enhance natural Fibonacci patterns in plants and other organisms, creating new varieties that are more efficient at capturing sunlight, processing nutrients, or resisting disease. The mathematical principles underlying natural beauty might guide us in designing new biological systems that are both functionally superior and aesthetically more appealing than existing forms. The spiral patterns we've explored tonight represent a small piece of this eternal mathematical reality. They remind us that beauty and order exist at the most fundamental levels of existence, and that human curiosity and creativity can uncover these hidden treasures through patient observation and playful investigation. Whether we're professional mathematicians, artists inspired by natural forms, or simply curious individuals who enjoy noticing patterns in the world around us, we all have the capacity to participate in this great, ongoing discovery of mathematical harmony. The Fibonacci sequence teaches us about the power of simple rules to generate infinite complexity and beauty. Starting with nothing more than the instruction to add the previous two numbers, we create a sequence that describes everything from the arrangement of galaxy arms to the structure of pine cones. This suggests something profound about the nature of reality, that the most complex and beautiful phenomena often arise from the simplest underlying principles. In a universe that can sometimes seem chaotic and unpredictable, the Fibonacci sequence reminds us that deep order and elegant simplicity lie at the heart of even the most complex systems. The golden ratio, emerging naturally from this simple sequence, provides us with a glimpse into the mathematical principles that govern growth and proportion throughout nature. Its appearance in contexts as diverse as human anatomy and spiral galaxies suggests that optimal solutions to the challenges of existence often converge on the same mathematical relationships. Evolution has discovered these optimal proportions through millions of years of trial and error, while human artists and architects have intuited them through aesthetic sensitivity and creative exploration. The psychological appeal of these mathematical patterns speaks to something deep in human nature, our innate ability to recognize and appreciate mathematical harmony. This capacity for mathematical beauty may be one of the things that makes us most human, distinguishing us from other species not just through our ability to create and understand mathematics, but through our emotional response to mathematical elegance and beauty. When we feel moved by the proportions of a classical building or the spiral of a nautilus shell, we're experiencing a profound resonance between our consciousness and the mathematical structure of reality. The therapeutic and healing properties of Fibonacci patterns and golden ratio proportions suggest practical applications for this mathematical knowledge. Healthcare environments designed according to these principles create spaces that promote healing and reduce stress. Gardens and natural spaces that incorporate these patterns provide restoration and peace for visitors. Music composed using Fibonacci proportions can calm anxiety and enhance focus. These applications remind us that mathematical beauty is not merely abstract but has real effects on human well-being and quality of life. The educational implications of understanding Fibonacci patterns are equally profound. When students learn mathematics through the lens of natural beauty and artistic creation, they develop not just computational skills but a deep appreciation for the role of mathematics in understanding and appreciating the world. This approach to mathematical education emphasizes wonder and discovery rather than rote calculation, helping students see mathematics as a living, breathing aspect of reality rather than an arbitrary collection of rules and procedures. The technological applications of Fibonacci principles continue to expand as our understanding deepens. Engineers use these patterns to design more efficient structures and systems. Computer scientists apply them to create algorithms that mirror the efficiency of natural processes. Materials scientists use them to develop new substances with optimal properties. As we face global challenges related to energy, environment, and sustainability, the mathematical principles revealed by the Fibonacci sequence may guide us towards solutions that work in harmony with natural systems rather than against them. The appearance of Fibonacci patterns in seemingly unrelated areas of science and mathematics reveals the deep interconnectedness of all knowledge. The same mathematical relationships that govern the growth of plants also appear in the structure of crystals, the behavior of financial markets, and the organization of computer networks. This suggests that the boundaries we draw between different fields of study are somewhat artificial, and that a truly deep understanding of any phenomenon requires appreciation for its connections to the larger mathematical tapestry that underlies all of reality. The fractal nature of many Fibonacci patterns, their tendency to repeat similar structures at different scales, provides insights into the way complexity emerges from simplicity throughout nature. The branching pattern of a tree is similar at the level of major limbs, smaller branches, and tiny twigs. The spiral structure of a galaxy is echoed in the spiral of a hurricane and the spiral of a seashell. This self-similarity across scales suggests that the same mathematical principles operate at every level of organization, from the quantum to the cosmic. The role of Fibonacci patterns in chaos theory and complex systems reveals how mathematical order can emerge from apparently random processes. Systems that seem chaotic at one scale often reveal underlying mathematical patterns when viewed from the appropriate perspective. The transition from order to chaos and back to order frequently involves mathematical relationships related to the golden ratio and Fibonacci numbers. This discovery has revolutionized our understanding of everything from weather patterns to population dynamics to the behavior of financial markets. The study of emergence, how complex patterns arise from simple rules, has become a central focus of modern science, and Fibonacci patterns play a crucial role in this research. Scientists have discovered that cellular automata, simple computer programs that simulate the interaction of many individual units, naturally generate Fibonacci-layered patterns under a wide variety of conditions. This suggests that these mathematical relationships may be inevitable consequences of the way complex systems organize themselves. Research in artificial intelligence and machine learning has revealed that neural networks trained to recognize patterns in visual data often develop internal structures that mirror the mathematical relationships found in natural vision systems. These artificial systems, when optimized for efficiency and accuracy, spontaneously discover the same proportional relationships that appear in biological neural networks and artistic compositions. This convergence suggests that the golden ratio and Fibonacci patterns may represent optimal solutions to fundamental information processing problems. The field of computational biology has used Fibonacci patterns to understand everything from protein folding to genetic regulation to evolutionary dynamics. Computer models of biological development often generate Fibonacci-layered patterns when optimized for efficiency efficiency and robustness. These discoveries suggest that the mathematical beauty we observe in living systems reflects underlying computational principles that govern how biological information is processed and expressed. Modern physics has revealed Fibonacci patterns in phenomena ranging from quantum mechanics to cosmology, the structure of atomic orbitals, the arrangement of particles in certain quantum systems, and the organization of matter on cosmic scales, all show mathematical relationships related to the golden ratio and Fibonacci numbers. These discoveries suggest that these mathematical patterns may be built into the fundamental laws of physics that govern the behavior of matter and energy throughout the universe. String theory, one of the most advanced theoretical frameworks in modern physics, incorporates mathematical structures that involve the golden ratio and related proportional relationships. Some theoretical physicists have proposed that the extra dimensions required by string theory may be organized according to mathematical principles related to the Fibonacci sequence. While these ideas remain highly speculative, they suggest that the mathematical harmony we observe in nature may reflect even deeper structural principles governing the fabric of space and time itself. The study of cosmological structures has revealed Fibonacci-related patterns in the distribution of galaxies, the formation of cosmic filaments, and the organization of dark matter throughout the universe. Computer simulations of cosmic evolution often generate structures that follow mathematical relationships related to the golden ratio, suggesting that these patterns may be inevitable consequences of the way gravity and other fundamental forces shape the large-scale structure of the cosmos. As we explore the implications of Fibonacci patterns for understanding consciousness and human experience, we encounter profound questions about the relationship between mind and mathematics. The fact that human beings seem naturally attuned to recognize and appreciate these mathematical relationships suggests something deep about the structure of consciousness itself. Some researchers have proposed that the brain processes information according to mathematical principles related to the golden ratio, which would explain why these patterns seem so aesthetically pleasing and psychologically satisfying. The therapeutic applications of Fibonacci patterns continue to expand as we better understand their effects on human psychology and physiology. Exposure to natural environments and artistic works incorporating these patterns has measurable effects on stress hormones, brainwave patterns, and immune system function. This research is leading to new approaches in healthcare design, stress reduction, and environmental therapy that use mathematical principles to promote healing and well-being. The educational revolution sparked by understanding Fibonacci patterns is transforming the way mathematics and science are taught at every level. Students who learn about mathematics through exploration of natural patterns develop not only better computational skills, but also deeper appreciation for the beauty and relevance of mathematical thinking. This approach helps address the widespread math anxiety that affects many students, replacing fear and confusion with wonder and appreciation. The environmental applications of Fibonacci principles are becoming increasingly important as we face global challenges related to sustainability and climate change. Understanding how natural systems achieve efficiency through Fibonacci-based organization can guide us in designing human systems that work in harmony with natural processes. Biomimetic technologies based on these patterns offer promising approaches to renewable energy, sustainable architecture, and ecological restoration. The space exploration implications of Fibonacci patterns may guide us as we venture beyond Earth. If these mathematical relationships are indeed universal features of natural organization, then we might expect to find similar patterns in any life-bearing worlds we discover. The search for extraterrestrial life includes looking for mathematical patterns in signals from space, and the discovery of Fibonacci-related patterns in alien communications would provide strong evidence for the universal nature of these mathematical relationships. The future of human enhancement and genetic engineering may be guided by understanding of the Fibonacci patterns that already exist in human biology. As we develop the ability to modify genetic information, knowledge of the mathematical principles underlying natural optimization may help us make improvements that work in harmony with existing biological systems rather than disrupting them. The golden ratio proportions already present in human anatomy might serve as guides for therapeutic interventions and enhancements. The development of new materials and technologies based on Fibonacci principles promises to revolutionize fields ranging from construction to electronics to medicine. Materials with internal structures based on Fibonacci patterns often exhibit superior strength, flexibility, and efficiency compared to those designed according to other principles. These discoveries are leading to new approaches in engineering that mimic the mathematical optimization communication strategies that evolution has perfected over millions of years. The social and economic implications of understanding Fibonacci patterns extend into areas like organizational design and economic modeling. Companies and institutions organized according to mathematical principles related to the golden ratio often exhibit greater efficiency and resilience than those structured according to other criteria. Economic models that incorporate Fibonacci-related relationships may provide better predictions and more stable outcomes than traditional approaches. The consciousness research implications of Fibonacci patterns suggest new approaches to understanding the nature of mind and subjective experience. If the brain processes information according to mathematical principles related to the golden ratio, then understanding these patterns better might help us solve fundamental questions about consciousness, perception, and the relationship between objective physical processes and subjective experience. The artistic and creative implications of Fibonacci patterns continue to inspire new forms of expression and aesthetic exploration. Digital artists use these mathematical relationships to create computer-generated works that seem naturally harmonious and appealing. Musicians compose pieces based on Fibonacci proportions that have unique psychological and emotional effects on listeners. Writers and poets experiment with literary structures based on these mathematical patterns, creating works that resonate with the mathematical harmony underlying natural beauty. The psychological healing applications of Fibonacci patterns offer new approaches to therapy and personal growth. Meditation practices based on visualizing golden spirals and Fibonacci sequences can induce states of calm and focus. Art therapy incorporating these patterns helps patients process trauma and develop greater emotional resilience. The mathematical beauty of these patterns provides a nonverbal language for expressing and exploring deep psychological truths. The ubiquity of Fibonacci patterns in human perception and cognition has led some researchers to propose that these mathematical relationships are built into the fundamental architecture of consciousness itself. According to this view, our brains may be naturally attuned to detect and appreciate these patterns because they reflect deep organizational principles that govern the structure of neural networks. This would explain why Fibonacci patterns and golden ratio proportions seem to have such universal appeal across cultures and throughout history. The ancient philosophical traditions were remarkably prescient in recognizing the fundamental importance of mathematical harmony in nature and human experience. The Pythagoreans, active in ancient Greece around 500 BCE, believed that all is number and that mathematical relationships were the key to understanding the cosmos. They were particularly fascinated by the mathematical ratios underlying musical harmony, discovering that pleasing musical intervals correspond to simple numerical ratios. This insight led them to propose that the entire universe was structured according to mathematical principles, a view that modern science has largely confirmed. The Pythagorean concept of the music of the spheres suggested that the planets and stars move according to mathematical harmonies that produce a cosmic symphony inaudible to human ears but detectable through mathematical analysis. While we now know that planetary motion doesn't literally produce sound, the modern discovery of Fibonacci patterns in astronomical phenomena suggests that the Pythagoreans were onto something profound about the mathematical nature of cosmic organization. Plato, building on Pythagorean insights, proposed that mathematical forms exist in a realm of perfect abstractions that serve as templates for the imperfect physical world we observe. According to Plato, the golden ratio and other mathematical relationships exist as eternal truths that physical reality attempts to approximate. This Platonic view of mathematics as a fundamental aspect of reality continues to influence philosophers and scientists today, particularly those who study the mysterious, unreasonable effectiveness of mathematics in describing natural phenomena. The medieval Islamic world made crucial contributions to our understanding of mathematical patterns in nature and art. Islamic artists and mathematicians developed sophisticated geometric patterns based on mathematical principles, creating artworks that seem to anticipate modern discoveries about fractals and self-similar structures. The geometric patterns found in Islamic art often incorporate the golden ratio and related proportions, creating visual harmonies that seem to resonate with fundamental mathematical truths. The Islamic mathematician Al-Kindi wrote extensively about the mathematical principles underlying music and harmony, extending Greek insights about numerical ratios to encompass broader theories about the mathematical structure of reality. Islamic scholars also made important contributions to the study of optics and vision, discovering mathematical relationships that govern how the eye perceives proportion and beauty. These discoveries laid groundwork for later Renaissance investigations into the mathematical basis of artistic beauty. During the Renaissance, the rediscovery of classical mathematical texts combined with new empirical observations to create an explosion of interest in the mathematical patterns underlying natural beauty. Artists like Piero della Francesca wrote treatises on the mathematical principles of perspective and proportion, while scientists like Johannes Kepler discovered that planetary orbits follow mathematical patterns related to the golden ratio and Fibonacci numbers. This golden spiral, born from the marriage of the Fibonacci sequence and the golden ratio, represents one of nature's most preferred growth patterns. It appears in the Nautilus shell, where each chamber is larger than the previous one by the golden ratio. It's found in the arrangement of florets in a sunflower head, where the spirals going clockwise and counterclockwise are consecutive Fibonacci numbers. It emerges in the spiral arms of galaxies, where stars and gas follow this same mathematical curve as they orbit around galactic centers. It's as if the universe has chosen this particular spiral as one of its favorite ways to organize matter and energy. The appearance of Fibonacci numbers in nature is so widespread and so consistent that it has a name, phyllotaxis. This term describes the arrangement of leaves around a stem, and remarkably, the angles between successive leaves almost always involve fractions related to Fibonacci numbers. A typical plant might have leaves arranged such that you have to go around the stem 2/5 of a full turn to get from one leaf to the next one directly above it. Both 2 and 5 are Fibonacci numbers, and this 2/5 arrangement, which corresponds to 44 degrees, is one of the most common patterns in the plant world. But why does nature seem to favor these particular mathematical relationships? The answer lies in efficiency and optimization. When a plant arranges its leaves according to Fibonacci spirals, it ensures that each leaf gets maximum exposure to sunlight and rainfall, while minimizing shading of the leaves below. When a sunflower arranges its seeds in Fibonacci spirals, it achieves the most efficient packing possible, fitting the maximum number of seeds into the available space. When a nautilus shell grows according to the golden spiral, it maintains its proportions as it grows, creating a structure that's both beautiful and functionally optimal. This connection between mathematical beauty and practical efficiency runs deep through the natural world. Evolution has discovered, through millions of years of trial and error, that certain mathematical patterns provide optimal solutions to the challenges of growth, reproduction, and survival. The Fibonacci sequence and the golden ratio aren't just beautiful abstractions, they're practical blueprints for success in the natural world. They represent solutions that work so well that nature has converged on them again and again in contexts as diverse as flower petals and galaxy formation. The ancient Greeks were among the first to recognize the special aesthetic properties of the golden ratio, which they called the divine proportion. They used it extensively in their architecture, most famously in the Parthenon, where the golden ratio appears in the proportions of the facade, the spacing of columns, and many other architectural elements. The Greeks believed that rectangles whose proportions followed the golden ratio were the most pleasing to the eye, and this belief has been confirmed by psychological studies showing that people do indeed find golden ratio rectangles more attractive than rectangles with other proportions. During the Renaissance, artists like Leonardo da Vinci became fascinated with the mathematical principles underlying beauty and proportion. Da Vinci's famous drawing Vitruvian Man demonstrates how the golden ratio appears in human body proportions: the ratio of total height to the height of the navel, the ratio of the navel to the fingertips, the ratio of the elbow to the fingertips, and many other body measurements all approximate the golden ratio. This discovery suggested that human beings themselves are built according to the same mathematical principles that govern flower petals and nautilus shells. Tonight we're going to embark on a journey through one of the most enchanting discoveries in all of mathematics, a sequence of numbers so simple a child could understand it, yet so profound it reveals the hidden architecture of the universe itself. We'll discover spirals that appear in galaxies millions of light years away, and in the chambers of a tiny nautilus shell. We'll find the same mathematical harmony in the arrangement of petals on a flower, the branching of rivers, the structure of our lungs, and the rhythm of our heartbeat. It's a story that begins with a medieval mathematician pondering rabbit populations, and ends with insights into the fundamental nature of growth, beauty, and life itself. This magical sequence is known as the Fibonacci sequence, named after Leonardo Fibonacci, an Italian mathematician who lived over 800 years ago. But the pattern he described has been dancing through the cosmos since the beginning of time, waiting patiently for curious minds to discover its secrets. The numbers themselves seem almost trivially simple: 0, 1, 1, 2, 3, 5, 8, 13, 21, 3, 4, 5, 89, 44. Each number is simply the sum of the two that came before it. Yet from this humble beginning emerges a pattern so beautiful and so universal that it appears to be one of the fundamental organizing principles of nature itself. Before we dive deeper into this mathematical wonder, let me remind you that tonight's journey is purely for the joy of discovery and the peaceful satisfaction of understanding, like watching the stars emerge one by one in the darkening sky, or listening to the gentle rhythm of waves against the shore. Mathematics at its most beautiful offers us a contemplative glimpse into the elegant patterns that govern our world. Tonight's exploration will take us through concepts that have amazed and delighted mathematicians, artists, architects, and scientists for centuries. We'll discover how a simple sequence of numbers connects the smallest flowers in your garden to the largest galaxies in space, revealing a cosmic symphony of mathematical harmony that plays silently all around us. Our story begins not with complex equations or abstract theories, but with something wonderfully concrete: a question about rabbits. In the year 1202, Leonardo Fibonacci posed a seemingly simple problem in his book Liber Aberci. He asked, if you start with a pair of rabbits, and each month every mature pair produces a new pair, and rabbits take 1 month to mature, how many pairs of rabbits will you have after a year? This practical question about animal populations would lead to one of the most important discoveries in the history of mathematics, a discovery that would eventually reveal the hidden mathematical structure underlying much of the natural world. To solve his rabbit problem, Fibonacci created a sequence that starts simply enough. In the first month you have 1 pair of rabbits. In the second month you still have 1 pair since they haven't matured yet. But in the third month that original pair produces offspring, giving you 2 pairs total. In the fourth month the original pair produces another offspring pair, but the pair born in month 3 isn't yet mature, giving you 3 pairs. And so the pattern continues: 1, 1, 2, 3, 5, 8, 13, 21, 3, 4, 5, 8. Each number represents the total number of rabbit pairs, and each new number is always the sum of the 2 preceding numbers. What Fibonacci couldn't have known when he devised this simple counting exercise was that he had stumbled upon one of the most fundamental patterns in all of nature. The sequence that emerged from his rabbit problem would later be found in the arrangement of seeds in sunflowers, the spirals of pine cones, the branching patterns of trees, the structure of galaxies, and countless other natural phenomena. It was as if he had discovered a secret mathematical language that nature itself uses to organize growth and form throughout the universe. The beauty of the Fibonacci sequence lies not just in its simplicity but in its universality. You don't need advanced mathematics to understand it, just the ability to add 2 numbers together. Yet this simple rule, applied repeatedly, generates a sequence that appears again and again in the most diverse and unexpected places. It's found in the number of petals on flowers. Lilies have 3, buttercups have 5, delphiniums have 8, marigolds have 13. In the spiral arrangements of pinecone scales and pineapple sections, in the branching patterns of blood vessels and lightning bolts, and in the proportions of seashells and human bodies. But the Fibonacci sequence holds an even deeper secret, one that connects it to perhaps the most famous ratio in all of mathematics, the golden ratio, often denoted by the Greek letter phi. If you take any Fibonacci number and divide it by the preceding number in the sequence, something remarkable happens. As the numbers get larger, this ratio approaches a special value, approximately 1:618:3398. This number, the golden ratio, has been considered the epitome of beauty and proportion since ancient times, appearing in art, architecture, and nature with such frequency that it seems to represent some fundamental aesthetic principle built into the fabric of reality. The golden ratio possesses properties that seem almost magical. If you have a rectangle whose length and width are in the golden ratio, and you remove a square from one end, the remaining rectangle will also be in the golden ratio. You can repeat this process infinitely, creating smaller and smaller golden rectangles, each one preserving the same perfect proportions. And if you draw a quarter circle in each of these squares, connecting them smoothly, you create what's known as the golden spiral, a curve that appears throughout nature with stunning regularity.